Hello everyone and welcome to the cumulative test number 2 review packet. I'm going to be going through every example in detail. So let's definitely start with number 1. Write an inequality for each graph. So if I take a look at part A, the shading looks like it's above the closed dot, which makes me think that I'm between greater than and greater than or equal to. Because the dot is closed, I know that it's included. So if I pick a letter like X, the shading has to be either greater than or exactly equal to -1. So this would be my answer algebraically for number 1, and this would be my answer graphically. Part B, it looks like this time that the 3 is not included because it's an open dot, and the shading is everything below -3. So if I were going to represent that algebraically, that would be X is just less than +3. Not less than or equal to because the dot is not closed. Number 2 asks to write a compound inequality for each graph. And as soon as I see the phrase compound, I think it's either going to be an and problem or an or problem, what we've been working on recently. And if I look at 2 part A, I notice that the shading is between 2 dots. And the time that that's come up the most often in our examples has been an and problem. If you think of it as graphing originally 3 and below, and then graphing -3 and above, if you think about taking these 2 graphs and pushing them together, it's going to overlap only in this green region, which makes me think that it has to be an and problem. So I have 2 ways I could possibly write that. I could write that X is greater than -3, put the word and in the middle, and at the same time, it's less than or equal to 3. So this is one way you could write the answer. You could also write it in kind of that strange and sandwich format, that X at the same time has to be less than or equal to 3, but at the same time, greater than -3. Now, in order to get something like this correct, I want you to notice that both of the inequalities are facing in the same direction. So if I was reading this piece, it would say X is less than or equal to 3, and if I'm reading this piece from the X, it would say X is greater than -3, which is the same as above. Part B looks like an or problem, because I could choose either to go forever towards the positives this way, or choose to go forever towards the negatives that way. And so the only difference is it had the word or in the middle. So I'd have either X is less than -2, which is true here, or X is greater than or equal to +1, which is this situation. Again, notice the open dot has no line underneath, the closed dot has the line underneath. Moving on to some solving. This first example, if I want to get X alone, I want to multiply both sides by -3 because currently it's being divided. Now I picked this example on purpose because we've been doing so many examples when you divide by a negative that you want to flip the inequality sign, but I want to remind you that if you would multiply by a negative, you also flip the inequality sign. So -24 times -3 is a +72, which means this is my answer algebraically. I'm going to write a note here that my inequality sign did flip. If I came over here to my graphical answer, I will do the symmetry thing we've been doing in class. X is less than or equal to 72 would be a closed dot on 72 towards the negative numbers. Number 4, if my goal is to get X alone, I would first subtract 8. 5/3 X is less than -7 and -8 is -15. If I want to move that 5/3 quickly, it's being multiplied. So to get it to the other side, I can divide by a fraction, which is the same as multiplying by the reciprocal. So over here, the 3's and the 5's cross out. So I'd have X is less than, and yes, it's still less than, because multiplying by a positive does not flip the inequality. On this side, -15 times 3 is -45. 1 times 5 is 5. If I divide -45 divided by 5, I have X is less than -9. So if I came Over here to the graph, I'd have 0, 9, negative 9. I would have a open dot on negative 9 because it's not included, and then I would shade again towards the negatives. Number 5 looks like we're going to have to do a little bit of distributive property first, and please just be careful with your signs when you're doing so. Negative 4 times negative 3 is negative 12z. Negative 4 times positive 2 is minus 8, or negative 8, is greater than or equal to. Negative 18z, negative times negative, is a positive 12. So if I want to move my z's together, I'm going to go ahead and add 18z to both sides. 18z minus 12z is 6z minus 8 is greater than or equal to 12. So now if I continue to get the z alone, I'm going to add 8 to both sides and get 6z is greater than or equal to 20. It doesn't look like it's going to divide in evenly, but if I do divide by 6, no, the inequality does not flip. It'll be greater than or equal to 26, which could be reduced to, let's see, if I divide both of these by 2, that will be 10 thirds. If you want to think of that for a graph though, 10 divided by 3 is really 3.3 repeating. So this would be my answer as a decimal, and this would be my answer here as a fraction. In terms of the graph, I'd have 0, 3.3 repeating, negative 3.3 repeating. I would have a closed dot on 3.3, and then I would shade greater than or towards the positives. All right, on to number 6. This time, I notice that I have like terms on the same side, so I'm going to combine those to be negative 4y minus 8 is greater than negative 12. I'm going to then add the 8. Negative 4y is greater than negative 12 plus 8, which is also negative 4. So now if I divide both sides by negative 4, this is a situation that if you divide by a negative, the inequality flips. So we'd have y is less than negative divided by negative, positive 1. So my graph would have an open dot on 1 because it's not included, and it's less than negative 1, so shading towards the negatives. Number 7, I am first going to distribute the 1/2, and remember distributing by the same, multiplying by a half is the same thing as dividing by 2. So this would be 24 plus 11x is less than half of 4 is 2x, half of 6 is minus 3. Now if I want to get the variables on the same side, I'm going to subtract the 2x to combine here. So we have 24, 11 minus 2 plus 9x is less than negative 3. Subtract my 24 to get x alone. 9x is less than negative 27. If I divide both sides by 9, again, this does not flip the inequality when you divide by a positive. So my answer would be x is less than negative 3. So my graph, going by 3's here, would have, again, yet another open dot on negative 3. And if I'm shading less than, just like number 6, it's towards the negatives. This next example looks like we're going to have to distribute on both sides to start and then combine like terms. So this would be 10g minus 15 minus 6g is greater than or equal to negative 2g, negative times negative, plus 12 plus 3. So on the left side, I can combine 10g and negative 6g. And on the left side, I can combine, or the right side, I can combine 12 and 3. So over here, we would have 10 minus 6, 4g minus 15 is greater than or equal to negative 2g plus 15. If I then want to get my g's together, I add 2g on both sides. So we have 6g minus 15 is greater than or equal to another 15. Continue to get g alone by moving that 15. So we'd have 6g is greater than or equal to 30. So if I then divide by 6, inequality does not flip. I have g is greater than or equal to 5. The graph would look like a closed dot on 5, and then greater than or equal to towards the positives. Number 9 is using the math vocabulary to create an inequality on your own. So let's definitely get to these as well. I do want you to solve each one also. Part A, the sum of a number and 14. So sum means the answer to an addition problem. So the sum of a number, which we'll call x, and 14 is less than or equal to 3 times the same number. So the number is x, so it would be represented as 3 times x. So this would be the answer to set up the inequality. But if I actually want to solve the inequality, we would have to get the x's together. So we'd have 14 is less than or equal to 2x. Divide by 2. So we'd have x is greater than or equal to 7. And you can more clearly see that. So if you take this entire thing and flip it around, the answer would be x is greater than or equal to 7. Part B, 7 times a number, so 7 times x increased by 8 represents that I'm adding 8, is at most 50. So if you see this phrase at most, that means it cannot go beyond that certain number. So if it can't go beyond that, it has to be less than, but it could be 50 itself. So it'll be less than or equal to 50. So this would be my original inequality, but if I would like to solve it, let me write that over here. 7x plus 8 is less than or equal to 50. We would subtract 8 from both sides. 7x is less than or equal to 42. Divide both sides by 7. So x is less than or equal to 6. Part C, 3 times the difference. So first, if I wanted to express the difference of a number and 8, difference means subtract. So the difference of the number and 8, so 3 times the difference. So that means that I'm multiplying this entire difference by 3, and that is no less than 40. So if it's no less than, that means that it has to be greater than. So this would be greater than, but it could also be equal to 40. So this is the answer to my inequality, all different colors I see there. If I actually wanted to solve that, again, let me write it out a little bit nicer. We distribute 3, add the 24. 3x is greater than or equal to 64. So if I divide both sides by 3, I again got a decimal. X is greater than or equal to 21.3, repeating. Part D, sorry about that, Part D, the quotient of a number and 2. Quotient is the answer to a division problem. So the quotient, which I'll write as a fraction, of a number and 2 is at least. So again, if you hear the phrase at least, that means that you're getting at least this amount of money, or you're getting that amount of money or more, which again is kind of unheard of. Your parents don't say, let me give you at least $20. So this would mean greater than or equal to the number 20. So these are kind of opposites. If you hear at most, it has to be that number or less. If you hear at least, it has to be that number or greater. So this is the answer to your inequality, but solving it, we would multiply both sides by 2, so it'd be x is greater than or equal to 40. All right, guys, feel free to go to the next video to continue starting with number 10. Thanks.